Hi everyone. On this section we're going to be talking about polynomials and polynomial functions. So we have to start out with a lot of terminology because that's just part of this section. We have to talk about what does it mean when we're talking about a term, and so you can see that I have terms right here, right? Term, and each one of these is considered a term. And then the coefficient is the numerical factor, right? Coefficient is the numerical factor of the term. And then I have some of those written out in this column. So they go with the term. So if this term was negative 1.2 x to the fifth, my coefficient is negative 1.2. And we're just going to say coefficient and not necessarily numerical coefficient, but it will be a number. Right? The coefficient of x cubed y is 1. The coefficient of negative z is negative 1. The coefficient of 2 is 2. And you can see that it's not with a variable, but we would still say that's 2. And then on the x to the ninth over 7, that's the same as 1/7 times x to the ninth, and the coefficient then is 1/7. Most of the time students say it's that number in front of the variable, and that's true. That's not the technical definition, but that's true. And then notice it says if a term contains only a number, it is called the constant term, or we can simply call it the constant. And so you may hear me use that terminology. You can still just call it a term. You know, a constant term is still a term. It's still a constant. However you want to talk about that is fine. Okay, so a polynomial is a finite sum of terms in which all variables are raised to non-negative integer powers and no variables appear in the denominator. If that were so, then they would not be polynomials. So we've got some examples here of, right, we've got some that are polynomials right here, and then we have some that are not, because notice we have a negative 3 for an exponent on the 5x, and well, I guess on the x really, and we have x squared in the denominator, and so neither of those would be considered polynomials. They look similar, right? They do. Okay, here's some more. So the following examples have polynomials in one variable written in descending order. Now descending order has to do with exponents, right? So we have the exponents. We have a 3, 2, 5 doesn't have an exponent. If we did write it with a variable, it would be to the 0 power. So that would be considered a 0 on that one, and we don't write that. And then notice we have an exponent of 2 and then the constant term, an exponent of 4, 2. This one is an exponent of 1. And also it's okay to have 8a to the 4th over 11 because the exponent is in the numerator, and that's perfectly fine. Okay, next we just have some special polynomials. We have some that we can call by a different name based on the number of terms. So if it's a monomial, it has one term. And you can see we have some monomials here and a list of those. Binomials will have 2 terms. Think about bicycle with 2 wheels. And then trinomials, a tricycle has 3 wheels, a trinomial has 3 terms. So if you hear me say monomial, I'm talking about 1 term, or a binomial 2 terms, trinomial 3 terms. And then after that, we just call it polynomials because we don't have any special names if we go beyond 3 terms. Okay, next, and there's more. So we're going to talk about the degree of a term. And I'm actually going to go back one. So when we're talking about the degree of a term, let's look at these monomials. Each of these has a degree. And then for binomials, each term has a degree. And so we didn't really talk about these, but we did talk about descending order. And descending order is by the exponent, which is also the degree. So like 4x cubed has a degree of 3, and 7/8 x squared has a degree of 2, and 5 has a degree of 0. So you can see that they're in order based on the degree of each term. So the degree is the sum of the exponents on the variables contained in the term. And this means in one term, right? The term is one term. So each term has a degree, and then we're going to talk about what do we say when we're looking at, say, a trinomial and the degree of the trinomial. So we'll get to that in just a minute. So it's based on exponents. So here we have an exponent of 3. So it has a degree of 3. On the 7, notice we don't have an exponent. You could consider this 7x to the 0. So that's why a constant term has degree of 0. So we're going to just say 0 on the degree. And you know, you don't need to write that, but that's kind of how you could think about it if that helps. On the next one, we actually have a degree of 3, and we have a degree of 1. We don't write the 1, so you don't see it, but it's there. And so we actually add those together. So this term has a degree of 4. And you know, these are all monomials that we're looking at. Now, notice it said, because we're getting to this one, -9 to the 11th, the sum of the exponents on the variables, whoops, I was going to highlight that, on the variables contained in the term. So when we look at this next one, -9 to the 11th power is simply a number, and it doesn't have anything to do with the degree for this term, but the 5 does. So this one has degree 5. And last, this is 9.11, so we don't really worry about that. We just look at the variables. Remember that the s actually has a degree of 1, just that has an exponent of 1. And so we're going to add the 2, the 1, and the 12. All right, so we have 2 plus 1 is 3, 3 plus 12 is 15, so this one has a degree of 15. So each monomial has a degree based on the variables and the sum of the exponents if we have more than one variable in that term. Okay, now we're going to talk about the degree of a polynomial. So this is something that you'll talk about down the road whenever you're solving equations. And when you're in college algebra, say, you have to find out how many solutions an equation might have, and the degree of a polynomial is going to tell you something about that. So knowing this is just something you need for the future. So if we look at each one of these, it says find the degree of each polynomial and indicate whether the polynomial is a monomial, binomial, or trinomial. And notice up here it tells us that the degree of a polynomial is the largest degree of all its terms. So if we look at this first one, we have a degree of 1 and we have a degree of 0. So this is degree 1, right? It has a degree of 1, and then it happens to be a binomial. Okay, let's look at the second one. So on the second one, we have a 2. Remember, that's a 1. This is a 0. And so that means that we have a degree of, I'm just going to say D, for a degree of 2. And then we have 3 terms, so this is a trinomial. Okay, next. So we have -7 to the 5th, so that exponent doesn't mean anything as far as degree goes. But the A, the B, and the C, right, degree 1, degree 1, degree 1, we're going to add those together. So this one has a degree of 3, and it is a monomial. Right, because there's just one term. And then last, we have a bunch of different things going on here. That's got a 1. This one has a 1. Okay, so let's look at these degrees. We have a 2 plus 1, so that one has degree 3. The next one has a degree of 2. And then we have a degree of 1. And then last we have a degree of 5. So now we know that the degree for this expression is going to be 5. So degree 5. Now this one has 1, 2, 3, 4 terms. Remember I told you we don't have a special name for that, so we just say, oh, this one's a polynomial, because it has 4 terms and we can't say what that means in this case. Okay, so this is about functions, and we're going to be finding the value of some functions. Notice it says this function p of x equals 3x squared minus 2x minus 5 is called a polynomial function because the expression 3x squared minus 2x minus 5 is a polynomial. And so, should I talk about expressions? All of these can be called expressions when we're talking about a polynomial, or in this case a function, because it says p of x equals, so we call those functions. Now on these we're finding just the function of values. This is evaluating, right? And so a q of 4 means I have to use the q function, right? So I'm going to say q of 4 equals 5 times 4 squared minus 1. So that would be 5 times 16 minus 1. And then 5 times 16 is 80. 80 minus 1 is 79. And on the second one, we're going to use the p function. Now you have to be careful when you're substituting with a negative number because you want to be sure that you square it correctly. I would use parentheses for your substitution to keep you from making mistakes. So if I square negative 4, right, negative 4 times negative 4 is 16. That's going to be minus 4 plus 1. And so when we combine this 16 minus 4, it's going to be 12. 12 plus 1 is 13. And then that's it for that one. You might want to use your calculator on the p to the 1/2. I'm just going to go below that because I'm of space. So 1/2 squared plus 1/2 plus 1. Okay, so we have 1/4 plus 1/2 plus 1. Now if I did a common denominator, and you could do this, you guys can use your calculator. This actually adds up to 1 3/4, which is 7/4. Remember, we like improper fractions in algebra, and we're not so good with mixed numbers. So you want to write it in this form, 7/4. Okay, so we are getting up about 13 minutes here. I'm going to stop this video and then I'll pick up the lesson on the next video.